Okay, divisibility rules. We all know how important divisibility is. So it turns out that there are some tricks and methods for finding out whether numbers are divisible by certain numbers. For example, you may know this rule for divisibility by 3. So let's look at how we can analyze this in terms of our decimal representation, right? So here's an example, 234. So is that divisible by 3? Well, 234 is 200 plus 30 plus 4. So that's 2 times 10 squared plus 3 times 10 plus 4. All right, but mod of 10, 3 is 1, right? If you take the remainder of 10 mod 3, you get 1. So if I take this equation and I take the remainder mod 3, now remember, if the remainder mod 3 of 234 is 0, then it's divisible by 3. All right? We can simplify the remainder calculation because we can expand out the 234, but we can replace 10 squared, we can replace the 10 with 1. We can replace the 10 with 1, okay? So instead of having 234, suddenly we have 2 plus 3 plus 4, okay? And that adds up to 9. So we have to take the remainder of 9 mod 3, which is 0. So that tells me that, yes, the 234 is divisible by 3. All right, we can generalize. Okay, there was really nothing special about the fact that 234 had 3 digits. We could do for any number of digits, right? If I take n and I take its decimal expansion, we've seen the same decimal expansion before, and I take the remainder of this mod 3, well, the remainder of dm times 10 to the n mod 3 is the same as the remainder of dm mod 3, because 10 to the m is 1 mod 3. All right, so we can just change this to, it went off the page there, but you can see how it's going to work out. It's just the sum of the digits. So an integer is divisible by 3 if and only if the sum of its digits is divisible by 3. So that's pretty cool. All right. So you may or may not know there's a similar rule for 11. All right. Is 6472 divisible by 11? Let's do the same thing. All right. So we want to take the remainder of 6472 mod 11. So let's take its remainder. We break out the 6472 in decimal representation. But what is 10 mod 11? The remainder of 10 mod 11, well, it's 10, but its modular equivalent to minus 1. So that's kind of a trick, right? 10 and minus 1 are modular equivalent. All right, so I can replace the 10 with minus 1 and not change anything. Okay, so what that means is that the odd powers of 10 are going to become odd powers of minus 1. The even powers of 10 are going to become even powers of minus 1. So you're going to get alternating signs. Odd powers of 10 gives me minus. Even powers of 10 gives me plus. So I alternate the sums of the digits, and if that's equal to 0 mod 11, then 6472 is divisible by 11. In this case, it's not, so it's not divisible by 11. Okay, but you can try this on some simple examples. For instance, 132 is divisible by 11. That's 12 times 11. 1 minus 3 plus 2 equals 0. All right, so that shows that it works in that simple case. All right, so we can do that. Now, you can see that this same kind of rule can be used for other numbers. In fact, it turns out that there's quite a simple rule for divisibility mod 37. Unfortunately, the spreadsheet didn't show here, but you can work out the powers of 10 mod 37, and there's actually a very simple rule for divisibility by 37. And there are other rules as well. Okay, here's 111. Now we can also do some kind of magic number tricks using this same sort of idea. So take some number, 321, then write the digits in reverse order, 1, 2, 3, and subtract the second number from the first. Well, you can subtract the smaller from the larger. All right, and you get this number here. Now, if you add the digits here, then you get 18, which is divisible by 9, and the same rule for divisible by 3 also works for divisibility by 9, and you can check and see why that's true. But since the sum of digits is divisible by 9, the result is divisible by 9. So no matter what you do with any set of digits, you can reverse them, subtract, and you get a number that's divisible by 9. Okay, so and now we know why that works. So that's a party trick you can try on your friends. There are other tricks as well you can do with 11, But these all have to do with modular arithmetic. All right, so modular arithmetic is really essential if you want to do magic tricks with numbers. It really also gives very deep insight into the structure of integers. So this was a short one. That's all we got for this section.